Hello class, today we're going to be going over Module 12 homework. Module 12 is on rational functions. A rational function is any function that is a ratio of two polynomials. So we'll have a polynomial in the numerator and it's being divided by a polynomial that's in the denominator. So let's get right into this. Number one, given the function h of x, list the function transformations on f of x equals 1 over x that creates h of x. So looking right here on this top, the 17, that's going to give us a vertical stretch. So a vertical stretch by a factor of 17. And then on the bottom, this is going to give us a horizontal shift. So it's going to be shifting, and specifically to the right, 1.8 units. And then determine the vertical asymptote of the function. So the vertical asymptote is the spot where the denominator equals 0. Remember, we can't divide anything by 0, so the function won't exist there. So what can we plug in for x that will make the bottom equal 0? Well, that's going to be x equals 1.8. And then determine the horizontal asymptote. To figure out the horizontal asymptote, what we want to do is we want to look at the ratio of the leading terms here. In this case, since there's no x on top and there's an x on bottom, when the ratio, or when the degree of the lower polynomial is greater than the degree of the polynomial in the numerator, the horizontal asymptote's always going to be 0. Okay, and then determine the vertical intercept of the function. So the vertical intercept of the function, well, that's going to be when x is equal to 0. So I'm going to evaluate this at h of 0, which is going to be 17 over 0 minus 1.8, which gives me negative 9.44. So our vertical intercept is at 0, negative 9.44. Number 2, given the function h of x, again we're listing the transformations on f of x, the parent function 1 over x that creates h of x. So this is going to have a vertical stretch by a factor of 4. The negative is going to give us a vertical reflection. And then we're going to have a horizontal shift left 3 units. Remember, when we're talking about horizontal shifts, it's the opposite sign. Okay. Now determine the vertical asymptote of the function. Well, that's going to be where the bottom equals 0, so we can plug it, if we were to plug in a negative 3, it would equal 0. So our vertical asymptote is x equals negative 3. Horizontal asymptote, again, the degree of the bottom polynomial is higher than the degree of the top polynomial. I'm talking about what the highest exponent is on the x term. In this case, there's no x on top, which means the degree on the bottom is greater than the degree on top. So this is going to be y equals 0. And then finally, determine the vertical intercept of the function. We're just going to plug in 0 for x. So h of 0 is going to be negative 4 over 0 plus 3, which is going to give us negative 4 over 3, which is negative 1.33. So our vertical intercept, we can say, is at 0, negative 1.33, just like that. Okay, going on to the next page. Number 3, the following image shows the graph, the parent function of f of x, In A, it says to sketch a graph of g of x on the same set of axes, where g of x is created by performing the following transformation on f of x. So the first part, the vertical shift up by 2, and then we have a horizontal shift left by 4. So let's think here. The intersection of the two asymptotes, we have a vertical asymptote at 0, at x equals 0, and a horizontal asymptote at y equals 0. Their intersection points of the two asymptotes are at 0, 0. So let's shift it up 2 and to the left by 4. So we go up 2, left 4, and this is going to be our new intersection of our asymptotes. So our vertical asymptote is here at x equals -4, and our horizontal asymptote is here at y equals 2. So if I were to sketch this, it would just be something like this, like that. All right. Now determine a formula for g of x in terms of f of x. So what happened to f of x? Well, let's first start off with g of x. G of x equals f of x, but what happened to f of x? F of x was shifted to the left 4 unit, so that's going to be x plus 4 in the parentheses. That's showing that it shifted left 4. And then outside the parentheses is how much it shifted up or down. The signs stay the same there. So it's going to be plus 2, just like that. Then determine a formula for g of x in terms of x. Well, our original form, f of x is 1 over x. So we can say that g of x is equal to 1 over x plus 4, right? Because we shifted to the left 4 units, and we shifted up 2 units, so plus 2, just like that. And then D, state the equation for the vertical asymptote of g of x. Well, we discussed that. That's at x equals -4. And then state the equation for the horizontal asymptote of g of x. And that's going to be at y equals 2. All right. Moving on here. Number 4, the total number of fish will depend on the size of a pond or aquarium. At the Reading Mandarin restaurant, a total of 90 tropical fish were placed in an aquarium. For the next 12 months, the total number of fish can be predicted by the function P of M, where P of M is the number of fish and M is the number of months since the fish were placed in the aquarium. So A, evaluate P of 8 and interpret the practical meaning of the answer. So here, we're just going to be plugging in 8 in for M. And after doing so, we're going to get 234. So what that means is after 8 months, there are going to be 234 fish. And then B, find the vertical intercept of the model. So here, we're just going to be plugging in 0 in for M. So P of 0 is just going to be, if you see, these are going to zero out, so it's going to be 90 over 1, which is just 90. So what does that mean? It means at the 0th month, or at the initial amount of fish was 90. So we can say the aquarium started with 90 fish. Awesome. And then find the vertical asymptote and state its practical meaning. Well, to find the vertical asymptote, we're going to set the denominator equal to 0 and solve for our variable. So we're going to have 1 plus 0.5m equals 0. That's going to tell us where the vertical asymptote is. So we're going to subtract 1 from both sides, and after doing that, we get 0.5m equals -1. And then divide both sides by 0.5, which will give us m equals -2. Now, what is the meaning of this? Well, in this case, there's not going to be a meaning, because we're in negative month land, right? This -2 would technically mean 2 months before the aquarium got set up. with the initial 90 fish. So this has no meaning. Then D, find the horizontal asymptote of the model and state its practical meaning. So here, for the horizontal asymptote, we want to look at the highest degree term in our polynomials. And when I say degree, I mean the highest exponent. In this case, this would be an exponent of 1. And since they both have an exponent of 1, when the exponents are the same of the leading term, then it's just the ratio of the two coefficients, the two numbers that are being multiplied to those variables. So the horizontal asymptote is really just going to be y equals 135 over 0.5, which will give us 270. So what does that mean? Well, we have to think about what asymptotes are. As we take x to infinitely large numbers, our f of x, or y value, approaches these horizontal asymptotes. So this is basically saying as we take the m value, the months, towards infinity, the number of fish are going to approach 270. So we can say, as the months go by, the number of fish, not fish, will approach 270. Okay. Then part E, determine a practical domain for the function. So the domain, let's see, the domain is going to be our month values, and we are given, if we reread the question, it says for the next 12 months the total of fish can be predicted by the function. So this model only exists, or only works for us, between month 0 and 12. 0 being the initial month, and 12 being the month where it says the model ceases to work. So this would be, so m is in between 0 and 12, and these are months. Okay. Then F, determine an associated practical range for the function. So here's the key word, associated practical range. So what is P of m when m is 0, and what is P of m when m is 12? So we'd evaluated it. Well, P of 0, if we evaluated, we know it started with 90 fish. We discussed that in part B. And if we were to evaluate P of 12, we would get 244.24. So our practical range, let's see, we're talking about fish, so we can't really have a decimal of a fish. So let's see, P of m is going to be greater than 90, or greater than equal to 90, but less than or equal to 245. I included the extra little bit there for us. I rounded up. So G, solve for P of m equals 187 and interpret the practical meaning of your answer. So we would use Desmos for this. And let's see here. Just give me a moment to type this in. I forgot to do it beforehand. Okay. And then let's see. All right. So I typed in our function, and then I typed in the line y equals 187. That's what it's asking for. It's asking to solve for P of m equals 187. So I graphed both of them, and we're going to look for the intersection point. And the intersection point is going to be our solution. So when P of m, when P of m is 187, m is 200 or 2.337. So m is 2.337. So what is this saying? It's saying approximately 2 1/3 month, right? A little more than that. At 2 1/3 months, there will be 187 fish. So about 2 1/3 months after starting the aquarium, there will be 187 fish. Awesome. Okay, on to the last page. So this last page, we are given different rational functions, and we need to determine the vertical and horizontal intercepts, if they exist. And then B, we need to determine the horizontal and vertical asymptotes. And then part C, use Desmos to graph the function and confirm your answers. I'll leave that for y'all to do. We'll just go ahead and do parts A and B. So let me get a piece of paper here so I have more room to work with. So for A, we need to determine the vertical intercept and the horizontal intercept. And for part B, we need to determine the vertical asymptote and the horizontal asymptote. So let's start with the vertical intercept. Remember, to do that, all we need to do is just plug in 0 for x and see what we get. In this case, we're going to get 6 over -5. Don't you see that if x were 0? So our vertical intercept is at 0, -6 over 5, or -6/5. The horizontal intercept. To do that, what we want to do is we essentially want to solve for x. Set our equation equal to 0 and solve for x. So let's see here. We have 0 is going to be equal to 6 over x minus 5. Let's get rid of that fraction, multiply both sides by x minus 5. Well, 0 times anything is 0, so this is going to be 0 equals 6. We know that is not true. So in this case, there is no horizontal intercept. When that happens, it does not exist. All right. And then finding our vertical asymptote. Remember, it's when the denominator equals 0. So what number can we plug in to make equal 0? Well, that would be x equals 5. All right. And then our horizontal asymptote, remember how we find that? We want to look at the leading terms of the top and the bottom. In this case, there's no x on top, and there's an x on bottom. When the degree of the polynomial is greater on bottom than the one on top, it's always going to be 0. So horizontal horizontal asymptote is y equals 0. All right. Let's go on to 6. So again, we're looking for the vertical intercept and the horizontal intercept, and the vertical asymptote and the horizontal asymptote. All right, so for the vertical intercept, let's plug in 0 for x and see what we get. If you do that, don't you see the top is 0 and the bottom is 2? So 0 over 2 is just 0. And then here, our horizontal intercept, think about it. If it crosses at the origin, isn't that also a horizontal intercept? Let's solve for x just in case, just to make sure, because there might be another one. There might be more than one. So we have 2x over 2x plus 2, and set the equal to 0, and solve for x. So multiply both sides by 2x plus 2. That's going to cancel out, so 2x equals, and this is going to 0 out, right? So if 2x equals 0, then x just equals 0, and there we have it, That's 0, 0. That's the only one. All right. And then the vertical intercept, or sorry, I keep saying that. The vertical asymptote, it's where the bottom equals 0. So can you imagine if we were to plug in -1 here, then it would 0 out, right? 2 times -1 is 0 plus, or sorry, is -2 plus 2 is 0. So our vertical asymptote is that x equals -1. Horizontal asymptote, again, we want to look at the leading terms here and look at its ratio. So in this case, we have an x on top, x on bottom. They're both to the first power. So we just want to look at the ratio of their coefficients. 2 over 2 is just 1, so y equals 1. All right, looking at number 7. Again, the vertical intercept, we're going to plug in 0 for x. When we do that, we're just going to get 4 over 1, which is 4, so our vertical intercept's at 0, 4. The horizontal intercept, we're going to solve for x here. So, let's see. We're going to set it equal to 0, so 4 minus 3x over 2x plus 1. Set it equal to 0. Again, we're going to get rid of this fraction. And you could probably see a trend that's happening here, right? 4 minus 3x equals 0, so whatever we always multiply by is going to 0 out. And then solve for x. So we subtract 4. -3x equals -4. So x is going to equal 4 over 3. So our horizontal intercept is at 4/3, 0. And then for our asymptotes, vertical asymptote, again, what number, if we plug in on the bottom, will make it equal 0? Well, in this case, I mean, you could set it equal to 0 and solve for it, but can't you imagine if I plugged in -1, or sorry, -1/2, it would 0 out, so -1/2 times 2 is just -1, plus 1 is 0, so that's where we're at. So x equals -1/2. And then our horizontal asymptote, again, we want to look at our leading coefficients. In this case, we have matching leading coefficients, our leading terms. We have matching degrees here. It's both of the first power. So it's going to be the ratio. So y is going to equal -3 over 2. All right. And then going on to 8. Okay, our vertical intercept, let's see, we're going to plug in 0 for x, and so that's going to give us 27 over 2, or it's just going to give us 13.5, so it's going to be 0, 13.5. Our horizontal intercept, we're going to be solving for x here. So let's see, we're going to set it equal to 0, so we have x cubed plus 27. Or sorry, that should be cubed. X cubed over plus 27 over x plus 2 equals 0. And we're going to, let's see, we're going to, oh, not even on the screen. There we go. We're going to multiply both sides by x plus 2. It's going to go away. That's going to remain 0. So x cubed plus 27 equals 0. And let's see. Let's just solve for it. So subtract 27. X cubed equals -27, take the square root, x equals -3. So our horizontal intercept is -3, 0. Vertical asymptote, let's see, if we plug in -2, that's going to give us 0 on the bottom. In the horizontal asymptote, let's see. This one doesn't exist. Whenever the degree of the upper polynomial is greater than the degree of the polynomial on bottom, we won't have a horizontal asymptote. We'll have what we call an oblique, or sometimes you'll hear it as slant asymptote. But in the case of a horizontal asymptote, this does not exist. Okay. Number 9, okay. So let's see. So here we're given functions that are in factors, right? So they look a little more complicated than what we had going on. So let's see. If I were to plug in 0 in for x, let's see what would happen. Well, can't you see that all the x terms will zero out? So what we'll really have is negative 3 times 5 over 6 times negative 8, if that makes sense, because everything else will be 0. So our vertical intercept is going to be negative 15, or negative 3 times 5, which is negative 15, over 6 times negative 8, which is negative 48. So it's going to be 15, or negative 15 over negative 48. And if you plug that into a calculator or get a decimal approximation, you would get 0.3125. Our horizontal intercept, let's see, we're going to be solving for x. So hopefully you've seen this pattern so far. Or you've gathered this pattern from watching me do this or having yourself do it. When we are solving for 0, or when we set equal to 0 and we are solving for the horizontal intercept, and every time we multiply by the bottom, can't you see that the bottom has just always gone away because it cancels, right? Whatever we're multiplying. And then this remains 0. So really, what we're doing is we're just solving for the top for x. So this just turns into x minus 3 times 6x plus 5 equals 0. And what we can do, since it's in factored form, we can set each factor equal to 0 and solve for each x. So x minus 3 equals 0, and 6x plus 5 equals 0. 0. So in this case, x is going to be equal to 3. In this case, 6x equals negative 5. Divide both sides by 6. So x equals negative 5 over 6. So our horizontal intercepts are at 3, 0. And we have 2 this time, negative 5/6, 0. All right, and then the vertical asymptote, that's where the denominator equals 0. So let's see, what numbers can we plug in so the denominator equals 0? Well, let's just solve for it. So we have it in factored form, so we can go ahead and set each factor equal to 0 and solve for each x. That's going to tell us what x value we can plug in that will give us 0. So we subtract 6 from both sides. 2x equals negative 6, which x is going to equal negative 3. And then let's see, 2x equals 8. Right? I just moved 8 over, and then we divide both sides by 2. X equals 4. So we have 2 vertical asymptotes. We're going to have one at x equals negative 3 and x equals 4. All right. Then our horizontal asymptote, this is what we're going to do. We are going to take just the x values and multiply them together, because we want to look at the leading terms when they're in standard form. And that's all we care about is the leading terms. So we're just going to take our x values and multiply them together. So this is going to give us, I'll just do it down here, if we multiply x times 6x, that's 6x squared, with some other stuff, right? I'm just not going to multiply the rest together. And then on the bottom, we have 2x times 2x. That's going to be 4x squared. And if I were to multiply the rest, we'd have more in standard form. Well, since in this case the degrees are the same, then we just take the ratio. So it's going to be 6 over 4 or 3 over 2. If you want to reduce. So y equals 3 over 2. Okay. one more. So let's do this. Okay. So let's see. To find our vertical intercept, we're going to, let's see. Hold on. What are we doing here? Gotta find the vertical intercept, the horizontal intercept. Okay. So the vertical intercept, we're just going to plug in 0 for x and see what we get. So let's see. We're going to have. Hold on. Let's see. What am I doing? Sorry, my brain just exploded here. So if we plug in 0 for x, we're going to have 4. Let's see. I'm just going to write over here. We're going to have p of 0 is going to be 4 times 2 times negative 5 over 7 times negative 3 times 4. Can you see that's what we would get if we plugged in 0? All the x's would just go away. So really what we have here, 4 times 2 is 8, times negative 5 is negative 40, over 7 times 3 is negative 21, times 4 is negative 48, or sorry, 84. There's a little bit of dyslexia there. And we get 0.476. So our vertical intercept is at 0, 0.476. Our horizontal intercept, we're going to be solving for x here. So let me get a scratch paper here. And let's see. So we have 4x plus 2, x minus 5, divided by 7, x minus 3, x plus 4. And remember, by setting equal to 0 and solving, this bottom just goes away, so we're left with 4 times x plus 2, x minus 5 equals 0. So what we're really doing is just solving the top. Since it's in factored form, let's let each factor equal to 0 and solve for each x. So we have 4 equals 0, which will never be the case. So there's not going to be an intercept there. And then x plus 2 equals 0, and x minus 5 equals 0. Solving for this, we get x equals 2, or sorry, x equals negative 2, and x equals 5. So our horizontal intercepts are going to be at negative 2, 0, and 5, 0. And then finally, our vertical asymptote, we're going to set the bottom, all the factors on the denominator equal to 0 and solve for x. So let's see. 7 equals 0. Oh, 7 equals 0. That's never the case, so that doesn't matter. X minus 3 equals 0, and x plus 4 equals 0. So we add 3 to both sides, we get x equals 3. Here we get x equals negative 4. So our vertical asymptote are going to be at x equals 3 and x equals negative 4. And then finally finding the horizontal asymptote. Let's see here. So let's just multiply all these, just our x's together. We're going to have x squared divided by x squared, but we do have these factors out front. So really what this is going to be, it's going to be 4x squared if we multiply all that together, and we have other stuff, right? I'm not going to multiply it together, divided by 7x squared. And there's a bunch of stuff after that I'm not going to multiply by. So we have the same degree polynomials on top and bottom, so it's going to be the ratio of the two, which is just going to be 4 over 7. So our horizontal intercept, or horizontal asymptote is at y equals 4 over 7. And that's it. So that is Module 12 homework. I hope this helped a little bit. And of course, let me know if you have any questions, and have a good day.